This project is a research project that our team is performing in collaboration with the New York City Department of Parks and Recreation. This is a green street, which is a vegetated space within the city that historically were built for aesthetic purposes and horticultural purposes and beautification purposes. But with the concerns that cities have about managing stormwater, sort of the newest generation of green streets are being designed to manage water.
We've been building this program since 1996, and we've installed 85 acres of green space in the roadbed. And in the past 5 years, we've started to experiment with stormwater capture techniques in order to reduce CSOs and bring water into our gardens. And this is one of the reasons we've created this relationship with Drexel University to evaluate the effectiveness of our designs and if they're actually capturing stormwater as intended.
So there's many different benefits that are associated with urban greening programs, and those can include stormwater management, reduction of urban heat island effect, and air pollution mitigation, as well as many others. But many of these services and benefits are directly linked with evaporative processes. Most notably, evaporation is a process that consumes heat and energy, and when that occurs, you reduce the temperature of the surrounding air mass. So by having green spaces like this throughout the city, you can reduce what's referred to as the urban heat island effect, whereby cities tend to be several degrees warmer than surrounding rural areas.
So our research is trying to document how well these technologies and approaches like this are for managing stormwater in urban environments. We have a weighing lysimeter, which is what's in that corrugated metal pipe, and that's just a section of the green street that is placed on top of a very sensitive scale. And by measuring the change in weight of that section of the green street, we're able to measure directly how much water is actually leaving to the atmosphere from the green street. We have a groundwater well over there, and we're able to compare precipitation patterns to groundwater fluctuations to see what types of impact on the regional water table we have by promoting infiltration in spaces like this. We also have arrays of soil moisture sensors. We'll have transpiration sensors in the sides of different types of vegetation. So we're really trying to dissect the water budget of this green street to understand how it works in an urban ecosystem and how that compares to what might have been here before development.
What's really exciting about this research is how we bring this together. So how do we sort of shape the future of urban ecosystems through the manipulation of water on individual parcels of land? That's, for me, one of the most interesting parts of this, is trying to really get back to some relevant ecological reference state. In all cases, it may not be exactly what was here before there were buildings, but how can we sort of design the future of the urban ecosystem in an appropriate way?